This is also a 16th, and it looks aesthetically pleasing, but this is not the cheapest way to make this part, if you can. Hey everybody, thanks for tuning in. We're making these videos as part of a longer series of videos that we're going to have both on our YouTube channel as well as on the resources tab of our website. We're hoping to just create useful content for engineers, buyers, and machinists, and just give back to the community a bit. And we thought a nice, easy first video would be talking about radiuses and how they're perceived by your local machine shop or manufacturing partner. And so yeah, we'll dive right into it. So when we get a part like this with no radius here, we're assuming that to function, the part could not have a radius. And so we're not going to go back and suggest that there be one or anything like that. We're just going to quote it as it was given us, unless we were kind of given any hints that somebody would like some DFM feedback on this. We don't really offer unsolicited advice, just because there are so many cases where, you know, these two parts look identical without the radius, but this part, it has to be this way. And we've seen that plenty of times where it just needs to be there to function. And so that happens all the time. So this part here, it's 5 inches by 5 inches, and it's 2 inches tall. And when we get a part like this at Priest Machining, we're going to instantly view it as a 3/0 part. So let's just talk about why. So our first op, we're going to machine the surface. We're going to face it. We're going to do these holes, either bore them or drill them. We're going to rough the outside and then finish the outside, and then do a chamfering op. And then we'll turn it over and we'll be on our second operation. And we'll just simply be facing it, removing the extra material and doing chamfers. And then we'll be turning it up on its side and doing the third op. And so this third op, it seems kind of like it would just be nothing. Like, who cares? Just do a third op. But each op adds a significant amount of time. Even something as simple as this can add a lot of time. So as I said, this is kind of a larger part. It is 3.5 inches from this top surface down to this surface, and so we're likely going to need a longer tool, and we're going to have to spend some time getting the speeds and feeds dialed for that longer tool, so that way it looks nice. You know, long tools tend to chatter, and so it might take a little bit of experimentation to get that to just look perfect. And then there's kind of two ways to approach this. The way we would likely approach it is we would have, like I said, roughed it and finished it in the first side, leaving a radius here that shouldn't be here. And so we'd come through and clean that up, and we'd be blending it with this face and this wall. Or we could have just left all this material here and left it as a solid rectangle, in which case we'd be needing to remove all this material in the third op. Either way, it's a significant amount of time compared to just simply having a radius here. Having this radius here eliminates all those extra steps. And just for planning purposes, even a simple op, we'd be probably quoting an extra hour or extra hour and a half just for the third op on this. Especially with lower quantities, you know, like if we just got to make one and do it right, you know, we're going to take our time and make sure that it ends up perfect. This isn't the greatest example. These parts are so simple. So with this radius here, how big do we want to make that? And in our opinion, the answer is as large as you can to fit the need of the part. You know, like if you have some kind of feature, something else that goes here in your assembly, this obviously can't just be, you know, a 3-inch radius. It would be sticking out to here and probably interfere. And maybe even just for weight consideration, you don't want it to just be absolutely ginormous, but the largest you reasonably can. And so here I modeled it with a 350 thou radius, kind of assuming here in our shop we would probably make this with a 1/2 inch or a 5/8 tool, it being 2 inches tall. like that. So yeah, that's this one here. Let's dive into this third part. This third part has quite a bit of features on it, and I've done this a couple times, so now I'm having to change it back because I've been playing around with it here trying to make those videos. So let me just quickly put it back to the way I had it for my demo, which is it's just a normal pocket here, and as it should, it has radiuses in the corner. But this one also has radiuses on the floor, and we see this a lot in aerospace. A lot of our aerospace clients will have this fillet on the floor, this kind of feature. And something that's super tempting is to make them all uniform and the same. So this is a 16th, and this is also a 16th, and it looks aesthetically pleasing, but this is not the cheapest way to make this part, if you can. Of course, there's scenarios where, hey, it has to be this way, and we totally understand that. But if you're trying to shave some costs down and make your manufacturing partner's life a little easier, you can make this wall a little larger. And the reason it gets a little easier is in this scenario where the upper radius, the wall radius, is larger, we can easily purchase a tool that's this diameter and has this radius on it. Whereas if they're uniform and identical, we are kind of forced to use a ball-end mill. It's just adding an extra tool to the situation, and also if they're identical, sometimes you're left with a little corner here that doesn't clean up, kind of like a cusp. And you have to do multiple passes to get it to clean up there. And so it definitely adds more time. The one other thing I would want to say about this situation where you have a pocket and of course radiuses in the corners, and you want to have a fillet all the way on the floor of the part, is don't be afraid to go super teeny tiny with this. Like say 20 thou here, or even as small as maybe 5 thou. Because that's a super easy, super common tool. Like we have plenty of tools that are 1/4 inch with a 20 thou radius here in our shop. We wouldn't need to purchase any custom tooling. Whereas if that was a bit larger, say it was like a 30 thou or a 60 thou radius, that's getting into more, it's a little bit more unique of a tool. So in this last two situations here, again, I'm remaking this, so I have to go back and change the feature to the way I had it. We'll just suppress that and then go up and add our little fillet here. Oops. And I made it a 15 thou radius. And so to machine this feature, we would need a 1/32 end mill, which is super teeny tiny. And if it's not necessary, it's just absolutely adding extra time. So potentially on a feature like this, if we were quoting this, we would imagine roughing this out with, say, 1/8 of an inch, just to get as close to that as we can. And then we'd come back and rough it out again with a 1/16 of an inch. And then we'd finally approach it with our 1/32 tool. And a tool, a 1/32 tool that is 200 thou long, that has 200 thousandths length of cut on it, or effective flute length, is it's just going to take a long time to do this corner and have it look good. And so if you have the ability to, you can add these Mickey Mouse ears. These are super easy to knock out tiny little radiuses. And so now you have effectively a square corner, minus the corner, of course. You have two square walls that you can butt something up against there. And if we see a feature like this, we're not even going to look at it at all. Whereas if we see little tiny radiuses, we start kind of really accounting for our time on those, just because we know that they're going to take a little bit longer to produce. Whereas something like this would just be included in, say you're ordering one of these, there would be no extra charge for anything like this. It would just be part of making the part. The last scenario are these fillets that go all the way around edges and features and parts, as you can see here. We see this a lot in the medical and life sciences. I don't know why that is. Maybe it's just to reduce possible burrs or sharp edges. I'm not sure, but we see it a lot with our medical customers, this tendency to put this fillet all the way around the part. And there's a few issues with this. The first is, let's just say it went around just this edge and this edge. That's pretty much no big deal, except for we're going to have to make sure we have that radius cutter on the shelf, or if it's like a rush job, we're going to end up just surfacing it, whereas if it was just a chamfer, it's a lot quicker and easier to just knock it out. The third issue with this, and you want to watch out for, is this feature here, like that, where these two fillets intersect, is just not practical to produce. So we could get as close as we can with, say, an end mill around this edge, creating the majority of that radius, and say we had the radius cutter, we could go as close to this wall without hitting it, and then we're going to be left with this weird little bump here where it's still square. And if this is absolutely a requirement, what's going to happen is it's going to end up being formed by hand with a file by one of our machinists, and that's just extra time. More often than not, so when we see something like this, we do usually call and ask, like, hey, do you want us to just get as close as we can, or do you want us to file it the best we can, or how do you want us to approach this feature, knowing that, you know, there's no way we're going to be able to reproduce this with the machine. And more often than not, we're told that it's not that important and just to make it a chamfer. But, you know, it's never up to us to say. So anyway, I hope that was useful, and I hope this was kind of a cool video. I'm sure a lot of the people watching this already knew a lot of this, but again, we thought it would just be like a nice, easy video to add to our resources. This is going to be up on our YouTube channel in addition to the resources tab on our website. Hopefully that'll be live approximately this week. It is the 28th of November. So hopefully within the week we'll have our resources tab set up, and we're hoping to add a lot of really cool stuff there. We've been working for the past couple months on getting all the content ready for this tab. And so videos are just going to be a small portion of that. So as always, please feel free to reach out to me either through our website. There's the contact form there. You can shoot me an email or message me, whatever works best. We would absolutely love to hear any feedback and start a conversation. So thanks so much.